Start real easy, and then we'll get real difficult in about 5 minutes. Okay? Review of grade 10. There's some smudge here. I guess it stands for A for angle. And you know the SOHCAHTOA stuff? You know how many grade 11s I have right now that forgot it? Yeah, a few. So there's the angle. That's opposite to the angle, so that's the opposite side. We usually start here and go, well, what's opposite to the right angle? That's the hypotenuse side. And then the weird one, the adjacent, which is adjacent to the angle. But you can also argue the hypotenuse. Isn't that adjacent to the angle too? Yeah. But then I say, but that's the hypotenuse. Anyway. You could always sit closer. That's 200%. Can I make it smaller? Is that what you said? Okay, sit further back. How about you and Brianna change spots? And we all be happy. Okay, so sine obviously is opposite over hypotenuse. So, right, ka, toa. No surprises here. You all just came through physics, most of you. Piece of cake, right? All right, let's move up a whole year, pre-calc 11. We've got some angle theta that went, rotated it through some angle theta, and this thing is now in standard position. So there's a terminal arm. Excuse me. That's better. It passes through point x, y. That's a coordinate, right? So to get there, you would move x, there it is, y, there it is, okay? And our trig ratios then are, this is what we'd call a radius if this was a unit circle. Or circle, but anyway. On a unit circle, the radius is 1. Okay? But before that, we would say, well, sine is opposite over hypotenuse. But here, the opposite is y, and the hypotenuse is an r. Cosine is adjacent over hypotenuse, but the adjacent, that's a distance x over r. Tangent of theta is O over A, which is y over x. And like I said in grade 11, if you want to try to, I just came up with a white highlighter so it does nothing. Try to memorize some strange sayings for that, be my guest, but it's pretty easy. 7 yellow wabbits, yeah. It's pretty easy to just draw the triangle and just figure it out, right? That's how I do it. I don't memorize all this. But I will tell you one girl who liked to say Tyrannosaurus Rex. That's how she memorized that tangent ratio. Show me. Tyrannosaurus Rex. And I'm like, well, careful, because there's an R in Tyrannosaurus Rex, and we don't want an R in tangent, but I don't know. I guess it worked for her, whatever. Okay, have you seen this stuff before? CSC, that says cosecant. That is just the reciprocal of sine. So if sine is y over r, what's 1 over y over r? R over y. Cosine, what's the reciprocal of cosine? Secant. Let's write that right there. Yeah, okay. All right, repetition's okay, yeah, all right. Secant is 1 over cos theta, that's also called 1 over cos theta. And cosine is x over r, so this is r over x. Now, should you memorize this? No, that would be silly. Okay, 1, 2, 3, 4, 5, 6 different. You just I will tell you what you do need to memorize. Cotangent. That's what COT stands for. And don't look on your calculator. There's no buttons for cotangent, cosecant, or secant. That's 1 over tan theta, which I won't write here. And so that's not y over x. Take the reciprocal of them. X over y. Now, what's really odd with this? How do you memorize that's 1 over sine and that's 1 over cosine? Because you would obviously think that sine would start with an S, and it doesn't. It starts with the C, which cosine starts with. So it's like opposite. That's how you memorize it. Okay? Is that stupid? Yeah, of course it is. That's the way it works, right? So sine starts with a C for cosine. Cosine starts with the S for sine, for secant and cosecant, okay? Cotangent, well, that's just, it says tangent in the word, so that one shouldn't be confused with the other two. Sorry, guys, it's how it is. I had to do it when I was your age, too, all right? But we were all smarter and better students back then, so it wasn't that big of a deal. Oh. Okay, something else I'm going to write on here is, you remember this? Cast. What the heck does that mean again? Yeah, well, let's start with this quadrant. You know, when we're graphing stuff, we want it to be positive, like, I don't know, objects going in the air and things. We don't want all the negatives. All the ratios are positive in this quadrant. X is positive, Y is positive. Any ratio of X, Y, and R, it's always going to be positive. Over here, what does the S stand for? Just sine is positive. That means the other two ratios are negative there. Okay? Because we're going to go negative X and then Y, or R is always positive. It's just a radius. Okay? So I'm not here to try to, we spent like 20 minutes in Math 11 me telling you this, so now I'm hoping it's just going to be, but if you really want to know, if you're confused, then you got to come in and ask me, right? T, only tangent is positive down here. The other one's a negative. And here, only cosine is positive. The other two are negative. Okay? So the way to memorize that is cast. And yes, there's other ways, okay? The confusing part is, for me at least, it doesn't start in the first quadrant, it starts in the fourth, and then you go counterclockwise, okay? All right, ring a bell? And of course, Pythagoras will always work for a right angle triangle. X squared and y squared is r squared. If r is 1, maybe it's a little simpler. And for unit circles, that's the definition of a unit circle. R will be 1. Speaking of which, then what would sine be if r is 1? What's anything over 1? Just the thing itself. Cosine is x over r, and if r is 1, then it's just x. So using that, it's pretty simple to do some coordinates, because the coordinates are x, comma, y in brackets, right? And if x is cosine theta and y is sine theta, then when we say x, y, all we want to do is just do that. There's coordinates for a unit circle. Okay, so we did this in Math 11, but it was all degrees. Now we got some radians. I think it'll be helpful if we do this in degrees first, because it's, sorry? Well, see, mathematicians say, what's the point of degrees? Why don't we teach everybody radians? It makes more sense. Oh, I said that last day. Look at the lesson. So degrees, how do I convert this to degrees? What's my conversion factor? 180 is equal to pi, right? And which one do I want on the top? If I want to go in degrees, I want to cancel radians. So radians is going to go on the bottom. And how many times does 6 go into 180? That is 30 degrees. Okay? So 30 degrees, well, you know what that looks like. You're familiar with that. That's it right there. We usually write it right there. What's the reference angle for that? 30 degrees. How far is it from the nearest x-axis? 30 degrees. Okay, it's in quadrant 1. So as a coordinate point, find possible coordinates for x, y. Well, this is a unit circle. So what do I know about x? It's just cosine 30. What do I know about y for a unit circle? It's sine 30. But I don't want to leave it like that. You remember these special angles that we'll actually do next day in Math 12? Do you remember some of these from Math 11? Sine 30? Some of you do. What is it? Yeah, there you go. See, you know it. It's a half. Cos 30. As a decimal, yeah, good. Exactly. It's root 3 over 2. Which is who puts in cosine 30 and gets 0.866? You all do, because you got a calculator. But exactly, that's what it is. This is just a decimal approximation, right? If it says write it to 4 decimals, then you put in 4 decimals in the brackets. No, it's root 3 over 2, not the square root of 3 over 2. Okay, and of course a half is 0.5. So that's what this thing is in degrees. We did that in Math 11. And I did say something to the fact that, yeah, you don't really have to memorize it this year, but it'll make it easier in Math 12. Of course, every one of you took the lazy way out, right? Okay, so that's what this is. So guess what? I already know I better get the same answer. So let's show you this in radians now. Pi over 6, first of all, where is that? I start here at 0. This is pi over 2. Half a pi, this is a whole pi, this is 1.5 pi, and I come around here again and I got 2 pi. That's a full revolution. That we should be having memorized before the end of the day, okay people? Alright? So pi over 6, where's that? That's a 1/6 of a pi. Here's half of a pi. There's a 1/4 of a pi. Where's a 1/6 of a pi? Is that less than a 1/4? 1/4 of a pi. There's pi over 6 there. Okay? So, possible coordinates. Again, coordinates are x, y. X is cosine theta. Y is sine theta. And the theta is pi over 6. So I got cosine pi over 6, sine pi over 6. Well, what's that as a decimal? Okay. Everybody, make sure your calculator's in radians. And you put in cosine of, where's my pi button on here? Pi divided by 6. Oh, look. Got the same darn thing. pretty soon, maybe we'll memorize that pi over 6 is root 3 over 2 for cosine. And pi over 6 for sine, pi over 6 is 30 degrees. Remember, that's a half, but let's put it in. Sine of pi over 6 in radians, hey, it's a half. So that's the coordinates to get to pi over 6 on a unit circle in radians. Same stuff, it's just in radians. If you see this thing, make sure your calculator is in radians. Okay? Are we having fun yet? So we did this, but it was in degrees. If theta is in between a whole pi and 1.5 pi, what quadrant would that be in? Pi over 2, 0, pi over 2, pi, 3 over 2 pi, 2 pi. It's in between, it's less than that, but it's greater than that, so right there. Also, let's write that. So this terminal arm is in quadrant 3. What else do I know? I know cosine of theta is negative 3 over 5. To get to this point, I got to go negative 3 over, this is a distance, remember, so it's always positive. Recall, you have to decide where to put that negative. Do I put it on the 3 or to put it on the 5? Obviously, in that quadrant, when I go left in the Cartesian coordinates, x is negative, right? So that kind of makes sense? Okay, 5, this is just a distance. It's always 5. I don't care where it is. Okay, it's like the radius. So that's what's going on. Find possible coordinates for x and y that's on the terminal arm of angle theta. X is negative 3. Do I know what y is? Yeah, I can solve for it easily. Remember the carpenter's triangle? 3, 4, 5. Yeah. 5 squared minus negative 3 squared, which is 9, is, what's 25 minus 9? 16. Square root of that is 4. But careful. Is that positive 4? It's got to be a negative 4, right? Remember, when you take the square root of something, it's plus or minus. In this case, I want a negative 4. Because y goes down. Okay, so what's the coordinates? Negative 3, negative 4. And I know it should be negative, negative, because it's in quadrant 3. Okay? Not okay? It will be fine. You will be fine. You will pass the test. There you go. Okay, this is about as hard as it's going to get. At least that's the hardest one that was in the assignment that they had the wrong answer to that I had to correct. This is in quadrant 4. Means piece of cake. It's over there. How would I get to this point, P, on that? I would have to go some positive x, and I would have to go some negative y, right? Cosine is a over a plus 1. But remember, cosine of theta, it is positive, but cosine is adjacent over hypotenuse, right? That's a right angle triangle. So where's the adjacent? That's there. Where's the hypotenuse? That's there. So draw the angle in standard position. Done. Sine of theta. What's sine of theta? Sine of theta is y over r. I got r. I just need to know y. Not quite as easy as the carpenter's triangle. Got to do a little bit of work here, right? So Pythagoras says c squared is a squared and b squared. So c, I'm given the hypotenuse. So c squared is a. I just don't know what b, let's call it y, is, right? So y is plus or minus the square root of that squared minus that squared. And that's the hardest thing about teaching like Math 8 and Math 9. It's like, do I start them here and then algebraically solve for that? Or do I just get them to memorize? If you're solving for a leg, just write it like that. I go back and forth all the time. Still don't know which way to do it. Okay, so what's this? Plus or minus the square root of that's a squared. Actually, no, I'm not going to skip a step here. Some of you guys still screw this up. A plus 1 squared is a plus 1 times a plus 1, right? Okay, that's your first step. That's a squared, and a, which is 2a. 1 times 1 is 1. And I'm going to subtract a squared. How many a squareds do I have, Reese? Thanks. Reese. Okay, so that is plus or minus the square root of 2a plus 1. Do I want the plus 1 or do I want the minus 1 for y? Yeah, it's negative. So I'm going to take the negative 1, okay? So that's what y is. Negative root 2a plus 1. So finally, sine is y is negative root 2a plus 1 over r, which is a plus 1. And Bob's your uncle. Okay. Lastly, what's tangent theta? I got all the ratios now. Should be a piece of cake. Tangent is O over A, or in Math 11 terms, y over x, which is negative square root 2a plus 1 over a. Let's do another, just because they're so fun. Who's got it already? What's cosecant mean? That's the reciprocal of? Good. You used my trick. It's a C, so it starts, it's the S one, it's the sine one. So 1 over sine. Here's sine right here. So all I'm going to do is flip those around, right? Okay? And so on and so on and so on. Sorry? Why do we need 1 over sine? Good question. Honestly, I don't have an answer for you that will make sense. That's a professor type question. They're lazy. No, I'm not a professor. They're lazy. They don't want to do 1 over sine. They just want to do something else that is 1 over sine. Right? So let's do cosecant. Don't worry, we'll be doing lots with those. We're doing trig for the next 3 chapters, right? What quadrant are you in if sine is greater than 0 and tangent, that's the hardest one, okay? These ones are easy. Where is sine greater than 0? Quadrants 1 and 2. Where is tan greater than 0? So where are you if this is true and that is true? Quadrant 1. We don't even have any cosecants or anything? Okay, whatever. I'm not going to do that one. All right, that's all you get. Quiz tomorrow on 4.1 and 4.2. Lewis, for the 3rd time.